It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Good evening all, welcome to Unacademy. My name is Bhanu Prakash, expert in GATE and ESE coaching. I did MTech from NIT Kurukshetra. I have 10 plus years of teaching experience, especially in the GATE and ESE field. And I train many students throughout our country for different competitive exams like GATE and ESE. I can teach the electrical machines and power electronics. BPC 10 is my referral code. Use this code, you will get 10% discount on the Plus subscription and Iconic subscription. Satish, good evening. Yes, Joshna, good evening. How are you? Sorry. So what are the benefits of the Plus and Iconic subscription? By taking Plus subscription, you can get live classes from the top educators of the country, and we have a choice of the teacher. For each subject, you can get multiple number of the teachers, so that according to your choice, you can select the teacher. And also one more structural schedule and unlimited practice questions for GATE and ESE and weekly test series. Okay, here we will improve your knowledge by taking the test series also. Here you will get by taking this Plus subscription. And another subscription is Iconic subscription. Iconic subscription, what are the advantages? One is the personal coach. The personal coach will guide everything until you get a job, and here it is a very useful for your GATE and ESE preparation. And second one is study planners. Okay, proper study planners for GATE and ESE preparations, and how to read, okay, how to prepare for the GATE and how to prepare for ESE, okay, effectively. This you will get by using this option, study planners, and expert guidance, and also ESE mains questions and answers. So these are the complete package of all the benefits, okay, so that it is a very useful for your GATE and ESE preparations. Okay, use my code BPC10, you will get 10% to discount on the Plus subscription and Iconic subscription. Okay. And what about the price for the Plus and Iconic subscription? By taking Plus, the Plus subscription is available for 12 months, 18 months and 24 months. For 12 months fee is the 27,225 rupees. For 18 months fee is the 34,650 rupees. Okay, for 24 months the fee is the 39,600 rupees. Similarly, another subscription, that is iconic subscription. So it is available for 12 months and 24 months. For 12 months fee is 35,225 rupees. For 24 months fee is 66,600 rupees. So this is about the fee structure of the iconic and plus subscription. Okay. And next one, how to install Unacademy learning app in your phone. So go to Play Store and search Unacademy learning app. So install this Unacademy learning app and access the pre-special classes. So to access these pre-special classes, there is asking invitation code. So use my code. So that is the BPC10. Okay, access my pre-special classes. Okay, I have taken many special classes based on the synchronous machine. So if you want to, you can access these classes. Use my code BPC10. So this is the Unacademy Gate Telugu December month schedule. Communication system 4 to 5:30 p.m. Nageshwar sir is dealing this subject. And engineering mathematics 5:45 to 6:45. Yankar sir is dealing this subject. Surendra Bob sir is dealing power system. Time is 7 p.m. to 8 p.m. And another one, aptitude 8:30 to 9:30. Ellen Sharma sir is dealing this subject. So he's a very good experience. He has a very good experience in the aptitude. So utilize these classes. And crash course, okay, power electronics. I'm teaching this subject every Saturday and Sunday 4 to 6 p.m. Another one, EDC 4 to 6 p.m. Aptitude 7 to 9 p.m. Okay, this is about the Unacademy Gate Telugu December month schedule. Okay, these are the some special plus batches taken by the top educators. You know, YouTube classes are the free, and special classes are all free to the students. And one more batches, that is the paid batches. These paid batches taken by the top educators of the country. So that is one batch is Target ESE Prelims 2021 electrical batch, and another one the rank booster batches for ECE and Target ESE Prelims 2021 electrical, the batch C running, and rank booster batch for Triple E batch B is running right now. So to use this effectively, please join as early as possible, and please take the subscription as early as possible. Okay, so this is a big day for our channel. The legendary educator is coming on 15th December 6 p.m. Be live at 6 p.m. Don't miss this live class. And it is Unacademy Combat. It is extremely useful for your GATE and ESE preparation, and also you can win some exciting prizes. It is India's largest competition for the GATE, challenging GATE questions created by the top educators. Super fast fun with the real-time rankings. Compete with the best. So just like a battle with the best. Okay, detailed video solutions by the top educators. So this is the December 16th at 6 p.m. The register now as early as possible, and also you can win some exciting prizes. So one is the first one, Apple MacBook. Second one is a Apple iPad Mini. Third one is the Apple AirPods for top under rankers. So you can get 1,000 Amazon watch, the rupees of 1,000 Amazon watches. Okay, so please participate, all of you, and make it success. So these are some batches for GATE 2022. EC batch A, it is in English and Hindi, starts on December 21st December. So please take subscription as early as possible. So some of our top educators are taking this batch. Okay, one is Ishal sir, Suresh sir, Siddharth sir, and BB Reddy sir. And next one, electrical batch. Okay, it is in the English and Hindi, starts on 21st December. Take subscription as early as possible. Okay, so these are the teachers taking this batches: Ankit sir, Ajay Gupta sir, Kwasir Apis sir, BB Reddy sir, and Suresh sir. So these are the top educators of the country taking the batches, starts on 21st December. So please take the subscription as early as possible. Use my code. Don't forget, use my code BPC10. So it's my code. You will get 10% to discount on Plus subscription and Iconic subscription. Good evening, Pawan. Okay. In previous class, we had discussed about lab connected armature winding of the DC machine. So we had discussed about how to design the lab winding, and also we had discussed what are the observations from the lab connected armature winding, and what are the number of parallel paths per duplex lab winding, triplex lab winding, and also the multiplex lab winding. Okay, multiplex. So equalizer rings are used to minimize the circulating current between the lap windings, and no dummy coils are required in the lap winding. All these points we have discussed in the previous class. Okay. All of it clear now? So today we will discuss about wave connected armature winding. So initially we will discuss what is the mean by wave connected armature winding. How do we connect the wave winding here? So example point I have taken here. So that is a 4 number of the poles. Okay. So this is a north pole, south pole, north pole and south pole, some commutator segment. So this is a starting end of the coils. Okay, here A in the sense it is the starting end of the coil. So coil 1. Okay, for example, it is a coil 1, starting end of the coil 1. So this end is a finishing end of the coil 1. Okay. Similarly, so let us assume this coil is treated as a coil 2. So it has a 2 ends. So one is the starting end of the coil 2, and similarly this is the finishing end of the coil 2 here. So how do we connect? Okay, how do we get wave connected armature windings? Okay, this is our question. So the finishing end of the one coil is connected to the starting end of the another coil under the adjacent pole pairs. Okay, suppose so this the finishing end of the one coil and under the same coil. So now this one is there. So in previous case, the finishing end of the one coil, in case of the lap winding, the finishing end of the one coil is connected to the starting end of another coil under the same pole pair. Okay, here is this is the one pair. Okay, one pair of the poles. Okay, and this is the second pair of the poles. So how do we connect the wave winding? The finishing end of the one coil is connected to the starting end of the another coil under adjacent pole pair. So if it is connected under the same pole pair, that is a lap winding. So here the finishing end of the one coil is connected to the starting end of the another coil under the same pole pair. So if in this way all the coils are connected in the armature core, so that winding is treated as a wave connected armature winding. Okay, so here also we have some terminology. So that is what is the mean by back pitch of the winding. So that is a YB. So back pitch here, and similarly YF. Okay, that is a front pitch of the winding, and another one is the resultant pitch. Okay, Y resultant. So this is the resultant pitch of the windings, and commutator pitch. Okay, it is a commutator pitch YC, and this is also commutator pitch, the YC values here. All of you got it point? Okay, these are the terms belongs to the wave winding of armature winding. Okay, So now how do we define the wave connected armature winding? This is our first question. So the finishing end of one coil is connected to starting end of another coil under adjacent pole pair if in this way all the coils are connected in the armature core. Okay, then winding is said to be wave connected armature winding. Okay, so this is the connections point of view. How do we connect the wave connected armature winding? All of it clear now? The finishing end of the one coil is connected to starting end of the another coil under adjacent pole pair. So if in this way all the coils are connected in the armature core, then the winding is said to be the wave connected armature winding. Why? Because successive armature coils are connected as like a wave. So the successive means side by side coils are connected as like a wave. So that's why it is treated as a wave connected armature winding. Okay, is that clear? And next, tell me what is the value of back pitch here? Back pitch is this is the back pitch in the sense the distance between the two coil side of a coil at back end of the machine is known as this is the commutator side is treated as the front end of the machine, and other side is treated as a back end of the machine. So what is the meaning of the back pitch? The distance between the two coil sides of a coil at back end of the machine is called the back pitch. And similarly, what about the front pitch? The distance between the two coil sides of a coil which are connected to the same commutator segment. So that is known as a front pitch of the winding. What about the resultant pitch? This part we have discussed in the lap winding. So resultant pitch means the starting end of the distance between the starting end of the one coil and starting end of the next coil to be connected. So next coil to be connected is called the resultant pitch. So this is the commutator pitch YC. So per wave connected armature winding, commutator pitch is not equal to 1. And also the resultant pitch is the sum of the back pitch plus the front pitch. Per lap winding, resultant pitch is a back pitch minus the front pitch. So these are the difference between the wave connected armature winding and lap connected armature windings. So now in this case, so per wave winding, Okay, wave winding. Okay, this is the resultant pitch is equal to the back pitch the plus the front pitch. Okay, and also commutator pitch is not equal to 1. Okay, but in case of the it is a some value, it is not equal to 1. So this is the in case of the wave connected armature winding, the resultant pitch is equal to YB plus YF and commutator pitch is not equal to 1. So this is equal to S commutator pitch YC is equal to commutator segments. Okay, commutator segments, this is the commutator segments. Okay, plus or minus, okay, 1 by the pair of the poles. Okay, that is the P by 2 values here. So that is the commutator segment or slots. Okay, so that you can write YC is equal to 2 into S plus or minus the 1 by PN. So this is the commutator pitch in case of the wave connected armature winding. How it comes, I will explain. Okay, why it is taken 2 into S by P, the S plus or minus 1 by PN. I will explain very clear. So now, are you clear my point? The per wave winding and the what is the resultant pitch and commutator pitch. Okay. Is that clear? అర్థమైందా అందరికి? వేవ్ వైండింగ్ లో కనెక్షన్స్ ఎలా ఉంటాయి, కమ్యూటేటర్ పిచ్ అనే దాన్ని ఎలా కనెక్ట్ చేస్తాం, ఎందుకు కమ్యూటేటర్ పిచ్ అనేది ఈక్వల్ గా ఉండదు. సో ఇన్ లాబ్ వైండింగ్ లో రిజల్టెంట్ పిచ్ ఎలా ఉంటుంది, బ్యాక్ పిచ్ మైనస్ ఫ్రంట్ పిచ్. ఓకే, బట్ కమ్యూటేటర్ పిచ్ ఈజ్ ఈక్వల్ టు 1 ఇన్ ద లాబ్, బట్ ఇన్ ద వేవ్ వైండింగ్ ద రిజల్టెంట్ పిచ్ ఈజ్ ఈక్వల్ టు సమ్ ఆఫ్. So how do we define the resultant pitch? Starting end of the one coil is connected to the distance between the starting end of the one coil and starting end of the next coil to be connected. That is the resultant pitch. So if it is connected back, okay, it comes from the winding connections back, then it is connected to the next commutator segment. But the winding connections are moving in the both side in the forward direction. So that commutator pitch is not equal to the 1. So in case of the wave connected armature windings. Okay. Is that clear now? Okay, listen. So what are the design specifications of the wave connected armature welding? So first design specification, see here, all of you. So this is the back end connections, right? So this connections is treated as the back end connections. Okay, these connections are treated as the front end connections of the machine. Okay, so here back end connections also moving from the left to right position. Am I right? Back end connections are moving from the left to right position, and front end connections are also moving from the left to right positions only. Okay, this connection is connected here. So this is the connected. Okay, it is the moving from left to right, and this is also moving from the left to right positions. Okay, these are the back end connections, and this one is a front end connections. Okay, all of you clear the point? So in wave winding, back end connections and front end connections are moving in the same directions. So both are moving the left to right, both are moving in the clockwise direction, or both are moving in the anti-clockwise direction per retrogressive wave connected armature winding. So that what we conclude here, so in case of the wave winding, back end connections and front end connections are moving in the same direction, so that back pitch and front pitch have the same side. So that means YB and YF are positive sign per progressive wave connected armature winding, and YB and YF are the negative signs, so per retrogressive wave connected armature winding. Okay, all of you clear my first point? Pawan, what is your question? What is the advantages and compare to left? I will tell you what are the comparisons later. First, let us know about wave winding clearly, then we will compare. Okay. So, first design specification, see. So, in case of wave winding, so in the wave winding, back end connections and front end connections. Okay, back end connections and front end connections are moving in the same direction. Moving in same direction. Okay, so that YB and YF have same sign. Same sign here. So that means YB and YF are positive for progressive the wave connected winding, progressive wave connected armature winding, and YB and YF are negative. Okay, negative for retrogressive wave connected armature winding. So we know that what is the meaning of progressive winding? The winding connections are moving in the clockwise direction. Okay, clockwise direction. So that is the progressive wave winding. So winding connections are moving in the anti-clockwise direction. So that is a retrogressive wave connected. So to make the winding in a clockwise, so we have to take YB and YF are positive. So to make the winding in anti-clockwise, so we have to take YB and YF are negative sides. So all of you clear point. So in wave winding, back end connections and front end connections are moving in the same direction, so that YB and YF are same sides. Okay. Is that clear, everyone? So next specification, second one is so here YB is equal to pole pitch. Okay, this is nothing but distance between the two coil sides of a coil. So YB also equal to pole pitch. Okay, that is the Z by P. Okay, number of conductors per pole, and YF is also the distance between the two conductors under the adjacent poles. So this one is it is also equal to the pole pitch Z by P values here. All of you got it, my point? So now here is a YB is equal to YF. Okay, this in case of the wave winding. So that is a YB is equal to YF. Okay, in wave connected armature winding. Okay, in the wave winding. In wave winding. So YB equal to, okay, YF. So that equal to Y average of these two. So that equal to the pole pitch. So pole pitch in the sense number of the conductors per pole. Okay, Z by P values here. So therefore you can write, so therefore here, so Y average is equal to YB plus YF, both are equal. That's why Y average also equal to the pole pitch values here. So now here this YB, if Y average is taken Z by P. So then what will happen in the question? So now question is, so if average pitch is equal to, okay, if average pitch is taken, very important, listen carefully. If average pitch is taken Z by P, okay, number of conductors per pole. So then what will happen in the winding? Then what will happen in the wave winding. Okay, this is our question. So let us take if the conductors example point of view. So we have taken the Z number of the conductor. P is equal to 4 pole machine and conductor Z is equal to, so this is the conductor Z is equal to the 16 number of the conductors. So therefore you can write the YB is equal to YF is equal to, so that is the Y average. So it is equal to Z by P values. So that is the 16 divided by 4. So it equal to 4, the YB is equal to Y. So here is a YB is equal to YF, that is equal to average. So if I take, okay, the average is a Z by P. So then what will happen in the wave winding? So when it is the 4, so what let us make the connections here. Suppose it is the back end connections, okay, back end connections of the machine. Okay, very important, listen, back end connections, and this one is a front end connections. Okay, back end connections depends on the values of the back pitch and front end connections depends on the values of the front pitch. Okay, that is equal to YF values here. So YB is equal to 4 and YF also equal to the 4. So YB is a positive sign. Okay, next one, and YF is the negative sign. Okay, negative sign. So now let us take first conductor at back end of the machine. So this is the first conductor at back end of the machine. The plus YB, so that is equal to 4. So equal to 5. So first conductor is connected to the fifth conductor at back end of the machine. So now at front end, the fifth conductor is connected to, okay, fifth conductor is connected to the ninth conductor at front end of the machine. All of it clear now? So ninth conductor at front end of the machine is connected to, so connected to the 13th conductors. Got it? 13th conductor. So now this 13th conductor is connected to the 17th conductor. The 17 in means what? Okay, 17 in the sense, so that is a 16 minus, okay, this is the 17 minus 16, that is equal to 1. So 17 in the sense that is the first conductor. So now again we are coming at first. Okay, all the coils are not connected in the winding. So how does it takes place in the winding? I will show you by drawing the winding. See, so first one we have taken 16 number of the conductors. So let us assume 1. Okay, this is the 2. Okay, 3, the 4, similarly 5th, the 6th conductor, 7th conductor, 8th conductor, 9th conductor, so 10th conductor, 11th conductor, 12th conductor, 13th conductor, 14th conductor, 15th conductor, and 16 number of the conductors. So let us give the numbers 1, okay, 2, and this is the 3, 4, okay, 5, 6, 7, 8, 9, the 10, 11, 12, 13, 14, 15, and the 16 number of the conductors. All of you got it? So these are the conductors. Now let us make the connections. So let us assume this end is a back end of the machine. Okay, back end of the machine, and this side is a front end of the machine. Front end of the machine here. So first conductor at the back end side. So it is connected to where? Okay, first conductor is connected to the 5th conductors. So this is a connected to first conductor is connected to the 5th conductor at back end of the machine. Am I right? So now this 5th conductor is connected to the 9th conductor, okay, through commutator segments. Okay, this is a one commutator segment. And next conductor is connected to, okay, this is the connected to the, okay, which one? 9th conductor is connected here, 13th conductors. So here 9th conductor is connected to the 13th conductor at back end of the machine. So now this 13th conductor is connected to, okay, this one is the connected the two, the which one? The first conductors. So now it comes from, okay, this one is comes from the, okay, 13th conductors. So now here is a winding will be completed per one round. Okay, all without connecting all the armature coils, which is the desirable or not? First tell me my question. So here, why, if it is taken, if average pitch is taken, if y average is taken, the z by p, then what will happen? Winding will be completed per one round without connecting all the coils in the armature winding, or all the coils in the armature core, which is undesirable. What will happen if the coils are not connected in the winding? So we can induce the less amount of EMF in the machine, which is undesirable. So that's what we have to do here. We have to connect all the coils in the armature core. That is our desirable. So here only 4 conductors are connected. Remaining 12 conductors are not connected. Okay. Not desirable. Very good. So if average pitch is taken, okay, what we conclude here? So if average pitch, y average is taken z by p, then winding will be completed. Winding will be completed per one round. Okay, winding will be completed for one round without connecting all the armature coils in the core, without connecting all armature conductors or armature coils in core, which is undesirable. which is undesirable. Okay, so all of it clear point, which is undesirable in the machine, so that in order to connect all the coils in the armature core, okay, in order to connect all the coils in the armature core, so plus or minus 2, okay, here is a plus or minus 2 integer is added to the number of the conductors. All of you got it point? So third design specification is here, third one. So in order to connect all the coils in armature core, okay, plus or minus 2, okay, plus or minus 2, the is added to number of the conductors. Got it point? So that means, so here y average, okay, that is the yb is equal to yf is equal to, so that is a y average is equal to, so it is a z plus or minus 2 divided by, okay, p, okay, plus or minus 2 divided by p. So this is the formula to get the values of the back pitch and front pitch. Okay, got it point? YB is equal to YF is equal to Y average. So that is equal to Z plus or minus 2 by P values here. So here Z is a number of the conductors, okay, where the Z is a number of armature conductors. Got it, mind? And next one, P is a number of the poles. Okay, these are number of the poles here. Now let us take same example only. So example point, we have a conductors. So that P is equal to number of the poles is a 4 and Z is equal to number of the conductors are 16. So therefore let us find out values of the back pitch and front pitch per wave connected armature winding. YB is equal to YF, so that equal to Y average, the equal to 16, the plus or minus 2 by, okay, P here, okay, P is equal to 4. So now simplify here, one is a 18 by 4, okay, this is the plus sign, 18 by 4, and another one is, okay, this is the 14 by 4. So 18 by 4 in the sense, okay, it is equal to how much? 4.5, okay, 4.5, and another one, it is a 3.5. So here what will happen? What is the difficulty here? So these are not integer numbers, okay, these are not, okay, not the integer, okay, integer numbers. Okay, all of it clear point. So it is the fractional numbers. So with 4.5 means suppose 1 plus, so 4.5, that is the 5.5. Is there any conductor 5.5? So it is a difficult. If the YB and YF are not integer, the winding connections are difficult. Okay, difficult here. So then what we have to do to make this to get the integer numbers? Okay, are you clear point? So if YB, okay, if YB not, if YB and YF are not integer numbers, okay, then what will happen? So winding connections are difficult, okay, integer numbers, then it is very difficult to make the connections. it is very difficult to make connections in the winding. Connections in winding. Okay, all of you got it my point? If YB and YF are not integer, then it is very difficult. Okay, very difficult to make connections in the winding. Is that clear, everyone? Then after that, what we have to do here to get the integer number of the values of the back pitch and front pitch? Is that clear? 3 points are very important. First one, in the wave winding, okay, back end connections and front end connections are moving in the same direction. So that YB and YF are positive sign for progressive wave winding, and YB and YF are negative sign for retrogressive wave connected winding. So in wave winding, actually YB is equal to YF, that is equal to Y average equal to the pole pitch. But there is a difficulty if your average pitch is taken Z by P. So what will happen in the wave winding? So what will happen? Winding will be completed per one round without connecting all the armature coils in the core, which is undesirable. So that what we have to do here? So in order to connect all the coils in the armature core, plus or minus 2 integer is added to the number of the conductors. So that is a YB is equal to YF, but that is a Y average. So that where you will get, okay. But there is, again, we have one more problem. We are facing another problem also. So if I add it like this, so what will happen? The here YB and YF are not integer numbers. Okay. So then after what we have to do? Anybody guess? So to make the values of YB and YF integer, we have to take the suitable conductors, or we have to choose the suitable conductor. So to get the values of the YB and YF are integer numbers. Are you clear my point? So fourth one here. So to get the integer numbers, okay, to get integer numbers of YB and YF, we have to choose the number of the conductors. So we have to choose or choose suitable number of armature conductors. Okay, armature conductors here. So if I choose this one is so for example point, suppose here slots is equal to example point here. So this is the slot is equal to 8 number of the slots. So that is the double layer winding. Okay, it is a double layer the winding. So this is so double layer winding means, okay, it means that the each slot, okay, here each slot, the double layer and single turn. Okay, these are not multi-turn. Just I have taken example point, the single turn kind. So each slot containing how many conductors? Each slot has the 2 conductors. Okay, got it point? So therefore number of the conductors, so that is equal to, so Z is equal to 16 number of the conductors. So now out of the 8 slots, so I am choosing the number of the conductor to make. So this YB and YF are integer numbers. So now that is we have selected okay, we have selected we have choose the 16 number of the, we have selected the Z is equal to the 14 conductors. So what it means, okay, this means, okay, that means there, so here one slot, okay, left empty, okay, this the left slot is left empty in the armature core, okay, here in the core here. So it means that suppose we have a armature core like this, okay, this is the armature core. So we have taken initially, okay, this one is a, okay, first slot 1, okay, slot 2, like slot 3 and slot 4, slot 5, slot 6, okay, slot 7, and this one is the slot 8. Okay, 8 number of the slots are there. So this is the slot 1, okay, slot 2, okay, slot 3 in the armature, okay, slot 4, slot 5, slot 6, slot 7, slot 8, okay, 8 number of the slot. So let us give the numbers 1, okay, 2, okay, 3, 4, the 5, 6, 7, 8 number of the slot. This is the core, armature core. So like this, suppose it is a cylindrical structure. So like this you can place, okay, it is the armature core, okay, this is the one front side, okay, just we are seeing this one. So here the E slot containing 2 conductors, okay, like this, okay, here 2 conductors. So one is the upper slot and lower slot. So this is the one slot, other slot. The similarly to E slot, 5th, 6th slot also containing the 2 conductors. So now these also containing 2 conductors, okay, like. So now let us give the numbers, okay, 1, okay, otherwise the 2, okay, 3 and 4 and so on, okay, here. But this slot is a lefty empty. So if I place the lefty empty here, so then what will happen? So it is not mechanically balanced well. Okay, this empty slot, okay, is a filled with the dummy coils. Okay, these are, so which are not connected in the winding. Okay, these are just filled. So some conductors are placed in the slot. So these slots are known as these conductors are, this coil is known as the dummy coils. Okay, dummy coil. So dummy coils are used in the wave winding to get the mechanical balance. Okay, this is the dummy coils are used in the wave winding. Okay, in the wave winding to get mechanical balance. To get the mechanical balance here. Okay, this is the function of the dummy coils. All of you getting? So dummy coils are placed in the slot, empty slot, to get the mechanical balance. Now let us see whether all the coils are connected in the winding or not with the number of conductors are 14. Okay. Suppose here we have a 16, the 14 conductors here. So example point here, the Z is equal to, so this is the P is equal to 4 and number of conductors Z is equal to 14 number of the conductor. So now let us find out Y average or YB is equal to YB. So that is equal to YF. So that equal to Y average. The what is the formula to get the average pitch? So it is equal to Z by P plus or minus, okay, 2 here. Okay, J plus or minus 2. Suppose if I take, okay, Z by P plus or minus 2. So this is the 14, okay, plus or minus 2, right? Z by P plus or minus 2 divided by P. So 14 plus or minus 2 divided by 4 number of the poles. So this is equal to 16 by 4 and the R, okay, next one, the 12 by 4 here. So by taking 16 by 4, you will get the 4 or the next one is the 3 here. Suppose here, this is a let us select. Okay, we can take 4 or 3. Suppose this one is a, okay, it is a, so it's the average pitch here. So that's why we can take, okay, here suppose if YB is equal to, okay, we will take the 2 windings. So average pitch is equal to, so here the Z by P plus R minus 2, so that you will get the 4 and 3. Suppose it is a odd number, okay, now this one is the even number, right? So if it is odd number, then you can take directly YB is equal to YF is equal to, so that is the Y average, okay, that is equal to 3. Okay, this is the 3 values. This is a one case. Okay, this is a case 1 also we will get the wave connected armature wire. Suppose if we take, if we get the even number, so this is the average is the even number. So that's why take like this. So YB is equal to, okay, 5 and YF is equal to 3. Okay, therefore, what is the average here? Y average is equal to, so 5 YB plus YF divided by 2. Okay, now you will get the 4. Okay, like. So this is also another possibility. Okay, that is the case 2 ones. So that what we conclude here. So this is the YB in wave winding. Okay, here. Okay, in order to get the wave winding, okay, this is a YB is equal to YF or difference by 2. Okay, this is the difference by 2 values here. But this is the suppose if I take, so we let us select the odd numbers. Okay, then let us see the connections. So what will happen? So back end connections and front end connections. Back end connection. Got it? So now this one is a connections. Okay, front end connections. Got it? So initially in case of the case 1 I have taken, what will happen? Back end connections and front end connect. So here back end connections YB is equal to, okay, 3 and YF also equal to 3. So YB in the sense it is also positive and YF also is a positive values. Okay, back end connection side, front end connect. Okay, YB and YF. So that is a YB is equal to 3 and YF is equal to 3. So now let us make the connections so that first conductor is connected to the fourth conductor at back end of the machine. Okay, back. So now here fourth conductor is connected to the seventh conductor at back end of the machine. Got it? So now seventh conductor is connected to, okay, that is a 10th conductors. So this 10th conductor is connected to, okay, 13th conductors. Got it? So now 13th conductor is connected to, okay, 13th conductor is connected to the 16. The 16 in the sense it is the second conductor only. Okay, 16 minus 14. So here Z is equal to only 14 conductors. So that's why 16 in the sense 2. So now second conductor is connected to the fifth conductor at front end of the machine. So fifth conductor is connected to the eighth conductor. So at back end of the machine. Okay, eighth conductor is connected to the 11th conductor at front end of the machine. So now this 11th conductor is connected to 14th conductor at back end of the machine. The 14th conductor is connected to the 17th conductor. Is there any 17? No. So that is the 17 minus 14, that is the third conductor. So now third conductor is connected to the sixth. The third conductor is connected to the sixth conductor. So now sixth conductor is connected to ninth conductor at front end of the machine. So this is the back end of the machine. So ninth conductor is connected to the 12th conductors. Okay, 2. So now here 12th conductor is connected to, so the 15th conductor. 15th conductor means that is the first conductor. So let us verify all the conductors are connected or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All the Z is equal to 14. 14 numbers of the conductors are connected. So now let us make the connections by using this winding table. Okay. Suppose I have taken, so first one, it is a conductor 1. 1, okay, 2, the 3, okay, 4 and 5. So this is the 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14th conductors. Okay, so Pawan, what is your question? In question given Z is equal to 16, then we have to select 14, or if it is a 16 is given, first to verify whether you will get the integer number or not with the given number of the poles. So if it is not integer, then take minus or plus or minus 2. Okay, there are the two possible. That means in the lap winding there is no restricted on the armature winding, but in the wave winding there is a restricted to select the armature winding. So why? Because in the wave winding there is a possibility of getting not integer numbers of the YB and YP. So to get that, so we have to choose the number of the armature conductors. Okay, so now here this one is a 1. Okay, first conductor is connected to the fourth conductors, right? Okay, fourth conductor, back end connection. So now fourth conductor is connected to the seventh conductor through commutator segment 1. Okay, like. So now seventh conductor is connected to 10th conductor through the commutator segment. This is the back end connection. And the 10th conductor is connected to 13th conductor through commutator segment. Okay, this is the commutator segment. So now 13th conductor is connected. Okay, that is the 13 plus 3, 16. 16 in the sense it is the second conductor connected to the second conductors. So it comes from, okay, this is the comes the from the, okay, 13th conductors. Got it? So now here 13th second conductor is connected. Okay, this is connected to the fifth conductors. Okay, through commutator segment. So fifth conductor is connected to 8th conductors. Okay, and 8th conductor is connected to the 11th conductor through commutator segment. Okay, and next one 11th conductor is connected. So this is the 11th conductor is connected to the 14th conductors. Got it? So now 14th conductor is connected, okay, to third conductor at front end of the machine. So it comes from the 14. Okay, this is the 14. So now third conductor is connected to the sixth conductor. The sixth conductor is connected to the ninth conductors. Got it? So now ninth conductor is connected to the 12th conductors. So 12th conductor is connected to, okay, which one? So it is connected to the first conductors. Okay, it comes from, so this is the from the 12, okay, 12 conductor. So let us assume here C1 commutator, C2 commutator, the C3 commutator, C4 and C5, and this is a, okay, this one is the the C6, okay, and here this is the C7, okay, 7 commutator segment. So each commutator segment is insulated by mica insulations, okay. So this is the complete winding with the first cases, okay. Arcane point. Suppose if I take the second case, then what will happen? Case 2 is a, so what is the case 2? So that is equal to y average is equal to, so here that is equal to 4. So this 4 here per progressive wave winding, per progressive wave winding. So we have taken, so this average pitch is equal to 4. So that's why to get the 4 average pitch, I have taken YB is equal to 5 and YF is equal to 3L. So that you will get average pitch is the difference by 2. Okay, difference by 2 here. So now let us verify back end connections and front end connections. So this is the back end connections. Okay, back end connections. Okay, and also front end connections. Front end connections. Okay, what is the value of the YB here? So it depends on the YB, that is equal to 5, and front end connections are depends on the YF, that is equal to 3. Per progressive winding, what about the sign? YB also positive and YF also the positive values. Okay, so now let us make the connection table. So first conductor is connected to the sixth conductor at back end of the machine. The sixth conductor is connected to, okay, here the conductors are 14 only. Okay, Z is equal to 14 conductors only. But we can make the back end connection and front end connections are the difference by 2. In the previous case, the back end connection and front end connections are moving in the same direction and also equal number. These are moving in the same direction are differenced by 2. Okay. And 6 plus 3, that is equal to, so 9. The sixth conductor is connected to the ninth conductor at front end of the machine. So ninth conductor is connected to 14th conductors, okay, at back end of the machine. So 14th conductor is connected to the 17th conductor. So 17 in the sense that is the third conductors, okay. So now third conductor is connected to 8th conductors, okay, 8th. So now 8th conductor is connected to, so this is the 13th conductors, sorry, it is not 5th. Okay, 8th conductor is connected to the 11th conductors. Got it? So now 11th conductor is connected to the 16th conductor. 16 in the sense it is the second conductors. Okay, second. Now here, so second conductor is connected to the 5th conductors. Okay, 5th conductor is connected to the 10th conductors. Got it? So now this 10th conductor is connected to 13th conductors. Okay, now 13th conductor is connected to 18. So this is the 18th conductor. 18 in the sense that is the 4th conductors. Okay, so now 4th conductor is connected to, okay, this 4th conductor is connected to the 7th conductors. So now 7th conductor is connected to, so 12th conductors. Okay, so now 12th conductor is connected to the 15. 15 in the means that is first conductors. So let us verify how many number of conductors are connected in the winding. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again 14 number of the conductors. So all the coils are connected. Okay. So let us make that same diagram. Okay. That is a 14 number of the conductors are connected. So here I have taken first conductor 1. So conductor 2. Okay. Conductor 3. Conductor 4. Conductor 5. Conductor 6. Conductor 7. Conductor 8. Conductor 9. 11. Okay. 10. 11. This is the 12. 13 and 14 number of the conductors. Okay, are you clear on point? Let us give the numbers here: 1, the 2, 3, the 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 number of the conductors. So first conductor is connected. Okay, see the back end. So suppose let us assume. So this is the back end connections, back end, and this side I have taken the front end connections, front end of the machine. So first conductor is connected to the sixth conductor at back end of the machine. So sixth conductor is connected to the ninth conductor through commutator segment. So ninth conductor is connected to, so this is the ninth conductor is connected to the 14th conductor at back end of the machine. So 14th conductor is connected to third conductor, so through commutator segment. Okay, this is the two commutator segment here. So next one, so this third conductor, okay, it comes from the 14th conductors. So from 14th comes from the 14th. So now third conductor is connected to 8th conductors. So 8th conductor is connected to the 11th conductor through commutator segment. So now this 11th conductor is connected to, so here the connected to the 5th 16 in the means second conductor. So it comes from the 11th conductors. Okay, from the 11. So now the second conductor is connected, okay, to the 5th conductor through commutator segment. Got it? So 5th conductor is connected to, this is the 10th conductor. So this 10th conductor is connected to the 13th conductor through commutator segment. So 13th conductor is connected. So it is connected to the 18 in the means that is the 4th conductors. So it is connected, okay, to the 4th. Okay, from, so this is the comes from the 13. So now it is connected, 4th conductor is connected to the 7th conductor through commutator segment. So 7th conductor is connected to, okay, 12th conductors. Okay, now this 12th conductor is connected to the first conductors. Okay, it is another, so connected to the first one. So it comes from the 12. Okay, from 12. Okay, now, so it is a commutator segment. Let us give the numbers: C1, C2, the C3, C4, okay, C5, the C6 and the C7. So number of the commutator segments are equal to number of the slots and also number of the coils. Okay, Z is equal to here 14 and coils is equal to how much? The coils is the 7 and slots also equal to how much? 7 number of the slots. Okay, commutator segments also equal to how much? So that is the 7 commutator segments. Okay, like this also we can make. So in the wave winding there are the two possibilities, okay, to make the connections. So one is we can take YB is equal to YF. Okay, it is a case 1. And case 2 here we can take difference of the 2 also. So but average piece is equal to some the integer numbers. Any more doubts? Okay, are you clear about these winding connections? Yes or no? All of you. So this is the procedure. I repeat once again. Listen. Very, very important for exams point of view. Okay. I will discuss all the questions. Okay. First one, design specifications point of view. So by using this, what we conclude here, YB and YF should be, okay, here is a, so what are the conclusions, okay, from this wave winding? So conclusions to get the wave windings. Conclusions to get wave winding. Okay, what are the conclusions to get the wave winding? So first conclusion here, see the average pitch, okay, y average should be the integer, okay, integer numbers, okay, integer, okay, and yb and yf also, yb and yf are, okay, integers, should be the integer numbers. So this one is a, okay, here it may be even number or odd numbers. So we can get the winding in both cases. Okay. So if it is a even number, okay, but YB and should be always odd numbers only. Okay, odd the numbers only. Okay, this is the conclusions. Okay. So are clear point? What is the average pitch and YB and YF? So next one, the wave winding is not possible with any number of the conductors. Wave winding is not possible with any number of the conductors. Number of conductors here. So that what we have to do here? So we have to choose the number of the conductors. We have to select the number of conductors. Select number of conductors. Number of conductors to get the integer values of the YB and YF. Okay, very important points. Suppose, but wave winding is a possible with any number of the conductors. But wave winding, there is a restrictions. So there is a restriction on the choosing the number of the conductors. Got it? Are you clear point? So next one. So we have some observations. Okay, this one is a very important observations from wave winding. Okay, exam point of view, 1 mark point of view, it is important. So observations from the wave winding here. So what are the observations from the wave winding? So first one, the number of the parallel paths. Okay, here parallel paths in wave winding. In the wave winding, so that is equal to A is equal to 2 only. Suppose if we take the brush position, then we will get the 2 number of the parallel paths. So next one, the number of the parallel paths in multiplex wave winding. Multiplex wave winding. Okay, so now that is a is equal to 2 multiplied by m. So where m is a multiplexity factor. So where m is equal to 1, okay, for simplex wave winding. Simplex wave winding. Okay, and m is equal to 2. Okay, this is the m is equal. Simplex wave means here this is a y average is equal to, so this is the z plus or minus 2 by p here. So this is the 2 multiplied by 1. Okay, y average. So now, and m is equal to 1. So m is equal to 2 for, okay, this is the for the duplex winding. Okay, this one is the duplex wave winding. So what is the meaning of duplex? To get the duplex wave winding, so this y average is equal to z plus or minus the 2 multiplied by 2. Okay, 2 multiplied by 2 by p. So generally, the generalized cases, so for multiplex wave winding, okay, this is the for multiplexity wave winding, multiplex just wait. So per multiplex wave winding, okay, wave winding, so this value y average is equal to, so z plus or minus 2 into, so here m divided by p. So this is the generalized formula to get the average value in the wave connected armature windings. Okay, so we have to choose, we have, in order to complete the all coils in the armature winding, so what will happen in the duplex, we have to multiply by 2 into multiplied by 2. So next for simplex 2 into multiplied by 1. Okay, like all of you clear point. So next one, the wave connected armature winding, another observation, third one. So wave winding is, okay, a winding is incomplete winding. Incomplete winding. So what is the meaning of incomplete winding? So that is the some slot. Okay, slot is empty. Okay, empty here. So okay, incomplete slot is empty. So dummy coils are required. Dummy coils are required to get mechanical balance. Okay, this function of the, sometime we have a question, function of the dummy coils, only mechanical balance purpose it is used. Okay, balance one. And fourth one, here problem of the circulating current. Problem of the circulating current is less in the wave winding. Less in the wave winding. Okay, because less number of the parallel paths. Number of parallel path. Okay, so equalizer rings are not required. These are the differences between the lap and wave winding. Equalizer rings are not required. Okay, but in the lap winding, so equalizer rings are required, dummy coils are not required. But in the wave winding, dummy coils are required, equalizer rings are not required. Okay, and fifth one, I already mentioned this point. So wave winding is used for, okay, wave winding is used for, so this is a high voltage, okay, and low current applications. Low current applications here. Whereas the lap winding is used for the low voltage and high current applications. So these are the complete observations from the wave connected armature winding. Okay, this is the, sometimes we have a questions. So how do we get the duplex wave winding, simplex lap winding? The simplex wave winding, you can take z plus or minus 2. But in the duplex here, 2 multiplied by 2. So per triplex here multiplied by 3. Okay, this is. And per multiplex here multiplied by m. Okay, is that clear, everyone? Okay, so now let us discuss one question here. A 6-pole lap connected DC generator generates the voltage of 400 volts. 400 volts. Got it? If same machine is reconnected as wave winding, then generated voltage will become dash. Okay, find out all of you. A 4-pole lap connected DC generator generates the voltage of 400 volts. The same machine is reconnected as wave winding, then the generated voltage will become. What is the value? If the greater than the 400 means that value mentioned the one will become in the volts. Okay, so we know the formula generated voltage EZ is equal to, so 5Zn by 60 into P by A, right? Where A is the number of the parallel paths. Okay, EZ inversely proportional to the number of the parallel paths. So this is the during the designing only. Okay, during designing. Okay, redesigning. So EZ is inversely proportional to the number of the parallel paths. Got it? So therefore you can write generated voltage, okay, in wave connected winding divided by generated voltage, so in the lap winding, okay, is equal to, okay, number of parallel paths in the lap divided by number of the parallel paths in the wave. So now simplify. So generated voltage in the wave is required. So this value is equal to, okay, 400 multiplied by the in lap, that is equal to 6 in the wave, number of parallel paths is 2. So it is equal to 400 multiplied by 3, it is equal to 1200 volts. Okay, this is the another question. Okay, next solve another question. A 6-pole lap connected DC machine as armature resistance of RA of 0.06 ohms. Okay, if same machine is reconnected as okay, as wave winding, then armature resistance will be dash in ohms. Okay, find it all of you. A 6-pole lap connected DC machine has armature resistance of 0.06 ohms. If the same machine is reconnected as a wave winding, then the armature resistance will be in the ohms. Satish, that's correct. Sanjana, 0.54. Okay, that's correct. Okay. Okay, we can connect, we can do, suppose see, a total armature resistance per 6-pole is given. So if the machine is connected as a lap, okay, if machine is connected as the lap winding, so then how many number of the parallel paths here? 6 number of the parallel paths. So let us assume this is the one, all the coils are, some conductors are connected in the series. So this is also the 6 number of the parallel paths. Okay, like, so this is the another parallel path, like so on. So it is the fourth parallel path, and this one is the third, fifth parallel path, and it is a sixth parallel path. Okay, clear point. So it is a how many parallel, six parallel paths are there? Six group of the brushes. So these are the positive group of the brushes. Positive group, not the positive brush. Okay, positive group. That is the three brushes. And this one is the negative group of the brushes I have taken. And here this is the positive group of the brush. Positive group means, so three brushes are connected in the positive. Okay, like, so it is a complete wave, the simplified manner. So this is a complete armature winding. Okay, this is a armature winding. So this is equal to RA. So that is the R equivalent, that is equal to RA. So that equal to 0.06 ohms. Okay. But what about the resistance per path? Okay, this is the resistance. Okay, resistance per path. How do we get here? So same value of the resistances are connected in the parallel. So therefore R equivalent is equal to, we know that in the electrical circuit we know very well. So resistance per path divided by the 6, right? So now this is the resistance per path, okay, in case of the lab. So that is equal to the 6 multiplied by R equivalent. So that is equal to 6 into RA. So that is the 6 into 0.06. So that is equal to 0.36. Got it, point? So this value is equal to 0.36 ohms. Okay, 36 ohms here. So if the same machine is reconnected as a wave, then what will happen here? So these three parallel path will become as a one parallel path. So these three parallel paths will become as one parallel path. So now therefore, if the same machine is reconnected as, just wait a minute, I will take one more slide. Okay, so if the same machine is reconnected as a wave, then what will happen? Listen. So in case of the wave winding, suppose here one parallel path, okay, one. So now this is the another parallel path, like, so parallel path in the wave lap winding. So three paths will become as a one path, okay, like this the 0 point, this value, okay, here. So here only two parallel paths in the wave. It is the negative group of the brush, and this one is the positive group of the brush's value. So therefore here, so this is the completely we required the RA value. Okay, here RA value. So we know already this value is equal to how much? Resistance per path in the lab 0.36. So this is also 0.36. Okay, this is also 0.36. So now resistance per path is equal to resistance per path. So in wave winding, so that is equal to 0.36 plus 0.36 plus 0.36. So what is the value of 0.36 here? So it is equal to multiplied by 3. 0.36 multiplied by 3 is equal to 1.08 ohms. But we required armature resistance in the wave. So that equal to R equivalent. So that is a armature resistance per path. So in case of the wave winding divided by 2 number of the paths. So this is the 1.08 divided by 2. So equal to 0.54 ohms. Okay. This is the one method to solve this question. And another way also we can solve. Okay. So how do we solve another way? So the second method to answer this question. So that is a circuit analysis point of view. We can answer like that. Here we can answer some another way also. Can you guess, anybody? Satish, ZR by A. Okay, see, if the machine is reconnected as a lap and wave, so that is the copper losses remain same. Okay, that is a, so copper losses, okay, copper losses or I square R loss, copper loss in the lap winding is equal to copper losses. This is the condition. Copper losses should be maintained constant. Copper losses remain same. That is the current and resistance value will be changed, but there is no change in the copper losses. Copper losses, okay, in the wave winding. Okay, wave winding here. So copper losses here means, okay, that is a current in the lap square the resistance in the lap. Okay, resistance in the lap winding. So that is equal to the current in the wave winding. Okay, wave winding. Okay, it is equal to the resistance in the wave winding. Okay, resistance in the wave. So from here we can write that this is a, so relation copper losses. Okay, this. So always we know that as the number of parallel paths, okay, number of the parallel path increases, parallel path increase, then what will happen? The current rating of the machine, I rating of the machine increases. Okay, machine will be the increased, right? So what we conclude from this case? So current rating, I rating directly proportional to the number of the parallel paths. Okay, number of, where A is a number of the parallel paths here. So directly proportional to the number of parallel path. Am I right? So therefore we can write the number of parallel paths in the lap winding square the resistance in the lap. So that is equal to number of parallel paths in the wave winding square the resistance in the wave winding. Okay, wait. So we require this value. So this is the relation. So use this relation, you will get an answer. So number of parallel paths in the lap. So that is equal to 6 square. So from the per given question. Okay, for given the question. Okay. So that you can answer this. How many number of parallel paths in the lap? 6 square. So resistance in the lap winding 0.06. So number of parallel paths in the wave winding, the 2 square. And we need the resistance in the wave winding, the resistance in the wave. So therefore resistance in the wave winding. So it is equal to 36 into 0.06. So divided by 4. So now calculate this value. So this is equal to 0.54 ohms. Like this also we can answer this question. Now all of it clear? Any more question do you want to ask? You can ask. So that is the first one. This, by using this method also you can answer. Okay. So So it is official Creatrix channel which has 150k plus members. Please join in this channel. It is Unacademy Gate Telugu Telegram group. Okay, to get any updates from the Gate Telugu Telegram group, please join in this group. Okay, these are the different type of channels under the Unacademy. One is a Creatrix Gate, Triple E, EC and Instrumentation, Unacademy Gate Mechanical, okay, Unacademy Gate Civil, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction, Unacademy Engineering Foundation, Engineering Patashala. Okay, thank you all. Thank you very much. Yeah, material will be available. So please join in this group. I will update the PDF of this copy in this Unacademy Gate Telugu Telegram group. Okay, మీరు ఈ టెలిగ్రామ్ గ్రూప్లో జాయిన్ కాండి. నేను PDF ఫైల్ దీంట్లో అప్లోడ్ చేస్తాను. యూ కెన్ డౌన్లోడ్ ఫ్రమ్ దిస్ గ్రూప్. Okay, any more question do you want to ask? Vivek, Benahar? All classes. ప్రతి క్లాస్ కూడా మీకు అన్ని క్లాసెస్ ఇదే గ్రూప్ నుంచి ఎవ్రీ ఎడ్యుకేటర్ అన్అకాడమీ గేట్ తెలుగు టెలిగ్రామ్ ఛానల్ ఎవరైతే టీచ్ చేస్తున్నారో వాళ్ళందరూ ఇదే గ్రూప్లో నీకు PDF క్లాస్ నోట్స్ ఉంటాయి. Okay.